nada, ¿me entiendes? Digo, si no se utiliza es tontería.
Hola, bueno, bienvenidos otra vez. Llevo un par de meses desaparecidos, estoy bastante preocupado. Pero bueno, ya estamos aquí otra vez. Y bueno, hoy os traemos otra edición de BADG, gracias a... Vamos a hacer el hashtag, como siempre, me olvidaba, BADG. Lo hemos simplificado, desde diciembre. Hasta ahí los retweets son bienvenidos, etcétera, etcétera, como siempre. Y bueno, por último, dar gracias a iDreams, que sabéis que es una agencia de viajes online, que nos patrocina, luego hay cervezas y pizzas, y bueno, vamos a decirle que nos sponsoren. Hoy va a hablar José, es un compañero de trabajo mío en MobileJazz, va a hablar sobre los WorkManagers, el Jetpack. Había la idea de que habláramos también del Pagination, iba a hacerla yo, porque es un pequeño apartado muy cortito, relativamente corto, pero revisando la charla de José se ha extendido bastante más y la vamos a dejar para otra, ¿vale? Entonces, bueno, sin más dilación, os paso con José y nada.
Vale. Venga, que todo se cargue. Vamos a ver que se cargue. ¿En inglés? Vale. Okay. Today, Marc already said I work with him in MobileJazz, that I will explain later. And we are going to speak about WorkManager, that it's a new tool or library. Okay. A new tool in the Android framework, let's say, component. That it's, well, I will explain later, because if not, I will explain everything here. Okay? It doesn't work.
Not working?
No.
Oh.
Okay, now yes. Okay, this is who I am. My name is José Luis Franconetti, software engineer at MobileJazz. I'm BADG. BADG is an internal product of MobileJazz, so that's why I work in both companies. I'm also a really fan of trail running, so just to give you more context. This is MobileJazz. We are a software consulting services company, and we are 100% remote. We don't have office. We had before in Barcelona, but we completely closed the office, and we work around the world. Okay, I'm working here in Barcelona, but most of the people are in Thailand, Europe, USA, etc. And this is BADG. It's a remote mobile app remote logger, crash and issue reporter, and in-app user feedback tool, all in one. Okay. Here you have a promo code if you want to use it. Okay, but it already have a free plan if you want to use it. Okay, but basically it's a remote logger for all your application. Okay, you can see all the logcat that you can see in your Android Studio in the web, okay? It's super nice in production because you can debug many things with this, okay? And it doesn't replace Crashlytics or Fabric, okay? It works nice, both of them. Honestly, I think that it's better to have both of them. Okay, so let's start with WorkManager, okay? I'm going to try to do the talk in the way that I learn WorkManager, okay? That's my approach every time that I enter in a new library or framework, and I will try to explain you all the research. What is WorkManager? That's the first paragraph in the documentation from Android, okay? And it says it's an API to specify deferrable asynchronous tasks and when they should run, okay? You see this and it's like, okay, it's nice, but we already have it in some way in Android. So that was like, okay, looks promising, but we already have it. So let's check what we have currently on Android that does the same. Threads, we can do this we can use threads for asynchronous task. We can use the jobs API, that you need to have API 21 loaders, services, async task, alarm manager, loopers, handlers, etc., etc., etc. Okay, we have many, many, many options to do this. So, but also there is external library that does the same. So this is the only one that I know I use. Okay, it's Android job. Everyone use it or not? Okay, no. So it does the same. Okay, the concept is you have a job, you schedule it, and it will be executed. It's from Evernote. Right now, it's not deprecated, okay, because that was my first thought when I saw that WorkManager is exactly the same as Android job. But what they are going to do is change the internal core of the library to use WorkManager instead, okay? So you can still use it because it has another feature that WorkManager doesn't have. Take a look because it's pretty nice library. So what are the benefits of WorkManager? Okay, in the documentation says that tasks are guaranteed to be executed. So the idea is that if I schedule a task, the system is going to guarantee me that it's going to be executed at some point. Okay, so that's something nice because, for example, with a thread, you are not sure that it's going to be executed because the application can be closed, the process can be killed by the operation system, etc. Tasks are executed when the constraints are satisfied. They start with a concept that, okay, I didn't know what it does that say constraint. Okay, so we will check it later, but the idea is that the task has a constraint and needs to be satisfied to be executed. And then say that it's an abstract API on top of the current Android stack, okay? What I said before, job scheduler, alarm manager, etc. So pretty nice. So how this actually works, because every time that I see something new on Android, I'm a little bit scared, okay? Because I don't really like too much what they do. Main concepts. Okay, in the whole WorkManager library, we have workers, we have work requests, and work request is basically an abstract class that they already have two default implementation. That one is called one-time work request and periodic work request. I think that the name explains at itself. Okay, one-time work, periodic work. Okay, this is almost everything. Okay, this is the main thing in the whole library. So let's define a problem, okay, that we are going to try to solve. Imagine that we need to store every 10 seconds a snapshot of the memory info of the current device in a storage database, okay? An analytics event, basically, okay? How we can do it, okay? The first thing that we need to do is create a worker, okay? It's the basic thing inside the library. So here we have a basic worker, okay? We extend from worker library. We need to pass the context and parameter that we will explain later. And we just need to override the doWork function. And inside that function, we need to introduce our business logic, okay? Here it's pretty simple, okay? We get the memory info, we create an analytics performance object, and we store it in the storage, okay? Right now. But if you see this code, you start to see things that I didn't explain. So for me, it was something completely new that I didn't know. The first thing that I saw is this. doWork, it's synchronous. So that's something that we need to be aware. We cannot play with callbacks, listener, etc. And if we play, we need to do it with a semaphore or something, okay? And then, what is a result, okay? Because here what they say, it's like, if everything works, success. If crash, the operation itself, if throw out an exception, we say failure. So what's a result? It's basically the class that defines the result of a work computation. Okay? And here we have all the possibilities that we can return in a worker. Okay? We have success, and then another one with data that I will explain later. Failure, the same with data, and another one that it's retry. Okay, so when you can see this API, you start to think that there is like a state machine inside the library, because it doesn't have 2 states, it has 3. So if we retry, it means that need to do it again. I don't know when, but it needs to be executed. What's the next thing? A work request. So to fix this problem, the idea was every 10 seconds, we need to create a snapshot of the memory info. So, okay, as I said, we have the one-time work request and periodic work request. Here we have a builder that we define which is our worker, sorry, and then the periodic one, by constructor, we need to pass the time and the time unit. Okay, this is something quite nice, I must say, because it's not really common to use the time unit in all the Android SDK. And for me, every time that I see a long number that say it's 1 minute or 1,000 per 60 per 60, it's like, okay, trying to change it to something like this that is more readable. So inside a work request, the next thing that I did was, okay, but what is the API of this object? Because I want to know all the options that it can provide to me. So here we have everything that we can set in a work request. The first thing is an input data. Okay? So the idea is that we can send information to the worker. That's something nice, because maybe in another worker it's something useful. But for this one, it's not. And we will explain later what the data means. We can add constraints. Again, constraints here. So, okay, let's check it later. Backup criteria. What it means is like you can define a backup of your work request. And what is a backup? It's basically a business logic when a work request fails or needs to be retried, when it's going to be scheduled again. Okay? An example of this is like, imagine that your application, this problem can be useful too. Imagine 10 seconds, 1 row in our data store, okay? And we don't send the information for a month. So we have a tons of logs, okay? And we start to send information to the server. Imagine that we have 2 million of devices sending information to the server. The server gets down. So the API responds as, no, it's not working. So in your work request, you are going to say, okay, retry, because we didn't send. We need to retry again. So if you don't have a backup, what it means is like when the server get up again, start working again, all the devices are going to try to send the information again at the same time. So what it's going to happen is that the server is going to be down again. So a backup algorithm, what it means is like you can have different ways of how to be scheduled again the work request. Okay? Here, to don't be linear, let's say. Okay? Here it's exponential. We have exponential or linear, and we can define, let's say, the starting point. Okay? We say 1 minute. They don't specify the algorithm that they are using under the hood, okay? But I must say that must be the typical one, and you can search it on internet. But it's basically a random that multiplies for this number, and that's all. The next thing, keep result for at least. This is something that, as I said before, all the work requests are guaranteed to be executed. So if they are not executed, they are in a data store. Save it, because if not, the system doesn't know in which state they are. So you can say to the system, please keep it, all the result or all the work infos for at least 1 day, etc. There is a maximum, but I don't remember, sorry. And why this? Because then you can search for the work info to get the information, to check if was completed, if wasn't, if there was an error, etc. And a tag. That for me was something that I say, why? I mean, why is this necessary? And they explain it in the documentation pretty well, and I really like it. Imagine that you have and scheduled the same problem, okay? 10 seconds, we save. But imagine that we also send it to the server. The server is version 8, okay? So we're using the version 1 of the server. Everything is persisted because it's guaranteed to be executed. So we update the application with a new API version. What it could happen is that the business logic of the sender request change. But the data can be also changed. So here, what we can define, it's like this periodic work request, it's going to work with a tag API version 1. So when we launch the update, we can say, OK, work, cancel all the work requests with the version 1, because we are using the version 2. So you are not going to have like strange crashes in your application because the business logic changes and you are sending something to the server that doesn't understand, okay? But we also have the one-time work request. It's almost the same, okay? The difference, it's the typical thing when you, for example, use a handler or alarm manager, that you say initial delay to be executed and an input merger, okay? That's something that we didn't have, and I will explain later, okay, what it is. So we have it there, and then we need to enqueue, okay? And this is the main entrance of the brain of the library, the WorkManager. And it's just get instance because it's a singleton, and you enqueue the request. And that's all. You can forget about it. This is going to be executed, okay? Guarantee. But in our problem, we say that required that the storage is not low. So here enter the next concept, constraint. Okay? So we can define a constraint like this, simple, a builder pattern, and we say, okay, storage not low, true. We build it and we set it. And that's all. If the storage is not low, it's going to be executed. Here, they didn't define what means not low. Okay, so that's something that we are not aware of. And I kind of not like, okay, because I want to know, at least. It can be less than 1 gigabyte, for example. Okay, but I want to know. Because, for example, with other tools, you can track it and you can know the storage of one device. So you can be sure if this was executed or not. We set it. Here is the whole API of the constraints. Okay, we can say storage not low, the type of network, connected. I think that you can define 3G, 4G, etc. Battery not low, charging, and device idle. Okay, I think that with only this, we don't need anything more. Okay, I think that they cover everything that we can have like as a constraint. And again here, okay, we enqueue, but what is a WorkManager, okay, instance? As I said before, it's the brain of the whole library. It's a singleton responsible of enqueue and cancel work requests, retrieve work information, and the definition of custom request change. Okay, and we will go through all of these concepts one by one and explain it. But we saw that it's a singleton, so how can we configure that? Here. You cannot have multiple systems of the WorkManager, and honestly, I think that makes a lot of sense, because if you have it, it means, imagine that if you want to guarantee that everything is going to be executed, you need to have a database behind. Okay, so if they allow you to have multiple WorkManager, they are going to have 2 databases. And then all the community, I know that it's going to ask why we cannot communicate between workers from different WorkManagers. And this is going to be a chaos. So having like a singleton, for me, makes a lot of sense, because it's going to be everything more simple. What we can configure inside a WorkManager? The first thing is the executor. I put it the not copy, please, because I don't know if someone knows what it means, direct executor, but it's basically, it's not going to launch the worker in a new thread pool. It's going to be executed in the same run loop. So it's going to be in the main thread, so don't copy. So when you define the executor, it's going to be the thread pool where all the workers are going to be executed, the do work function, okay? That's part of code, but not the whole WorkManager. This is something that we cannot control, and we don't know how they did it. We can specify the job scheduler job ID range. If you already use the job scheduler library, that was, I think, was released the last year, if I remember properly. But you can, every time that you create a job, you define an ID, okay? So if you cannot have conflict between the WorkManager and your current code with the jobs IDs. So here you can define a range for the WorkManager to create the hypothetical jobs. And you can be sure that this is not going to be a conflict. Minimum login level. Max scheduler limit. This is basically to define a maximum of requests that it's going to be sent to the job scheduler and alarm manager. And that's why, because these 2 classes are pretty heavy inside the system, so you don't want to have 20 or 30 at the same time running, okay? Because that's something that you are not going to control. So I don't know here, 15, the default, okay? We build the configuration, and we initialize the WorkManager, and then we can use the get distance. It's going to have that configuration. The first thing, enqueue and cancel API. Here we have the whole API of the WorkManager to enqueue and cancel work requests. Sorry. We can enqueue, or we can send a list of work requests. When you send a list of work requests, means that it's going to be possible to be executed in parallel, but you don't know. But you need to be aware of this, because your code needs to be concurrent. If not, it's going to be a crazy night at some point. Then we have enqueue unique work. And the difference, it's like we can define a string and a policy, and then we pass the request or the array of requests. The same for the period work request. But the policies are different, and we will explain now. And then we can cancel. And as you can see here, we can cancel by tag, that is what I already explained, like the API version 1, or for example, changing the library. You're using OK HTTP 2 and then 3, you can cancel everything, or unique work, okay, 2, the same as before, or by ID. But here we can see this policy. At that point, I want to know what this policy does. Here, we have the policy of the one-time work request. We have replace, keep, and append. I put this directly the screenshot because the comments are pretty nice, pretty self-explanatory. So I really like. Replace, what it's going to do. When you enqueue again that work request, if some of them is pending or uncompleted, it's going to be replaced, and that's all. And you can imagine, why do you need this, for example? Oh, I have the example in my mind. I forgot it. Okay, let's continue. I will think again. Keep. The same. If it's pending or uncompleted, I don't care. I will keep it. Okay. I will overwrite the current one. No, overwrite. No, sorry. I will keep it. It's like. Sorry, I completely forgot it. What are they saying? You do nothing otherwise. Okay. Yeah, it's not going to be replaced or nothing. The system is not going to do anything at all. Okay? It's not going to enqueue that work request. And then we have append. That it's basically appending a new work request in the queue. I told you all the example this morning.
The chat status?
Yeah, the chat status.
While you are typing.
Yeah, for example, the replace for the chat status. If you have a socket that is sending you the typing, the it's reading, etc., you can always use the replace because you always want to have the latest state of that request, work request. Okay, so with this you can be sure that it's going to have the latest one. And append, for example, can be Spotify. You are adding new thing to a playlist, so you are appending work request that the business logic it's only appending a new song, for example. Periodic work policy. It's only have replace and keep. And that's the same, but only for the periodic one, okay? Fetch, worker information. Here we have all the API to fetch the worker information. We can do it by request ID, by tag, or by unique work. But we have two different API. It can give us live data and listenable future. Who knows what is a listenable future? Okay. Listenable future came from a Google library. It's basically the utility library from Google from the beginning of the world, let's say. It came from backend, the Java. But in Android, it never been so popular because at the beginning was such a big library that the DEX, the method count, grow like crazy. But I have been using it for years, okay, because it gives you a lot of things. And this is something, it's listenable feature. That it's basically a feature in Java, but the problem with the feature in Java is that it's only synchronous. The only way to get the result of an execution is synchronous.get. But a listenable feature, it gives you a listening, so you can attach a callback, and it's going to give you the result asynchronous and synchronous. So, for example, all the typical interfaces that we have in our code, like onComplete listener, and we have on success, on failure, and we pass it through the functions. We can remove it. We can return a listenable feature directly. It's going to give us that specification, okay? But listenable feature, I can give a talk only about this, okay? But that's something pretty nice that they added inside the framework, and it's a dependency, okay, from the WorkManager. And why they use it? Because live data, it's going to be like coupled with your UI, okay? Because you need to be aware of the life cycle of your application. But imagine that you are using it, the work info, the fetch the work info information from a use case, okay? An interactor or a database, a data store, whatever that it's not a screen. You can use the listenable feature because it's not needed to have like a context or the life cycle or anything at all. Okay, so it's going to be pure Java, not Android. Okay, here we have it. And here it's how we use it. It's the normal API. I think that you already know how to use the live data. And we can, here for example, we are checking that it's not null and it's subsist, the work info. We can have it asynchronous or synchronous at the end with dot value. And this is the example with the listenable feature. .get, synchronous, asynchronous, we can have it adding a callback, and we have on-set, on failure. And here again, it's a direct executor, but that's something common in listenable feature. We need to give them an executor where the operation is going to be executed, okay? Or at least, in this case, it's for the callback, okay? For the on success and on failure. Or we have another option that it's add listener, and this is only be called when it's completed, because it's not going to give you the work info. If you have questions, please stop me, okay? But here we have a new concept that came. It's called work info. So say the information from the result of a work. Here we have contain the information of a work request. And here it's you can see the API. We have an ID that is a UUID, an output data. Again, we have a data, and we will cover it later. A state, all the tags, because we can have multiple tags in a work request. Simple. A state. So here is the first time that they are starting to give us more information about the state of the work request. This is the screenshot from the last I/O, okay, the official keynote. This is how a work request is going to be executed. And here you can see the three states of the result. When it starts, it's blocked, because they don't know if they have enough resources or the constraints are satisfied to be executed. So when something, for example, the constraints are satisfied, they enqueue the work request. And then running. And while running, you can retry, cancel, or failure. And that's all. But this is the life cycle of the work request. Data. Here it comes. Let's see what it is. Responsible to send information in out between work requests. It's a simple key value map where all the keys are the strings. We cannot change that. And the values are primitives, or they arrive of themselves. List a Boolean, list of Boolean, etc., etc., etc. And it's limited to 10 kilobytes each data object, okay? After being serialized. So we cannot save here like a ton of information or like a bitmap, for example, in blob. So take care of this. And this is the API. For me, it's like a bundle. It's the same as a bundle, okay? A key value map with the primitive, and that's all. But they don't have the blob option in the data. This is pretty important. Take into account that this is not a data store, okay? You shouldn't use it to save, like, for example, send the logs, okay? So we validate the logs, for example, and we say, okay, these logs need to be sent, and you are using another work request. Don't save that logs inside the data, okay, because it's not what they are supposed to be. You, for example, can save the URI of a file, and then in the other work request, use that URI to open the file and do something, IDs, etc., etc. Recap the problem one, because we enter in the API every time, and we need to finish. Here we have it. We have the constraint. We say that the store and not low. We define the periodic work request, add the constraint, and enqueue. And that's all. We can go home. That this is going to be executed and working if your business logic it's properly well. Chain work request. I already say that in the API of the WorkManager say that you can chain work request. Okay, so here let's create a new problem. This problem doesn't make any sense, but for the demo I think that it's nice. Imagine that as we are saving the performance every 10 seconds, and then we have inside of our application analytics event. Every time that click a button, open a screen, we are saving an analytics event. And we need to send it to a server. But before, we have like a policy, or like the project manager came and say, no, the information needs to be in that way. So we need to validate all the information that we are saving in our database to be able to send it. So let's start to fix that problem. This is a bit bigger, but don't need to be worried because we need only take care in two parts. But the first thing, we create a worker. The first one, it's going to be validate analytics model. We get all the analytics, we filter it, okay? And then, as I already say, we save it to the database in a way, let's say, we need to send it. That's all. It's like an state inside our data store. Why we are doing this? Because we are not going to send the logs. What we are going to send is the UUIDs of our logs. So here I say, okay, I need, after this validation, I need to return a success with all the UUIDs of the logs that are validated to be sent to the server. So here we have it, okay? We create a data that it's a utility function that is called work data, but you can use the constructor of the data. But this is already in the library. And it's a pair, basically key value. So here we have the key that is going to be model UUID and the UUID. And we return the result. And that's all. That's what we need to do until now. Let's go with the next one. It's completely the same, but this one are the performance events. We filter everything and we return the UUIDs. Let's continue. Now we need to send it to the server. So we need to get the information from the previous workers. We have an input data that we already say. So we get it, the information from the key, and we have the UUID, we query, we send it, and we delete it, and we return subface. That's all. How we can chain it. The first thing I say, okay, let's make more constraints. The first one is battery, not low. The next one, we need to have a connection. Then we need to create the work request. The first one, it's going to be the validate analytics model. The next one, validate performance, and the next one, analytics. Okay, and for the first two ones, we are going to say that it's not going to be executed if the battery is low, because imagine that you have thousands of millions of logs, and it's going to drain the battery. And the sending to the server needs to be connected to internet. And here we have it. this is how we change the request. We say, okay, WorkManager get distance, and begin with. We say, okay, start or begin with this work request. And as we have two, we put it in a right. Again, this can be executed in parallel. Take care of this. And when these two requests are completed, we concatenate with them. It's like a Fluent API that they build, and it's pretty nice. And we put it the same analytics event work and enqueue. And at that point, that operation, it's going to be atomic in the state. Okay? The same analytics is never going to be executed until the previous one are executed successfully. If one fails, it's not going to be sent until it's a success. Sorry. Something that came to my mind, it's like, imagine that you have the same key in two work requests, and it's going to be changing. What happens when we are merging it? Because at the end you are sending it to one. It's a bottleneck. Okay? You have two work requests and the send request that it's only one. So what happens with the information? What it's going to do? And here it's going to enter the input merger that I said before. In a work request, you can define, as I say, an input merger. And it's basically an abstract class that allows you to define how the information is going to be merged. Sorry. By default, the framework provides us two implementations: a write creating input merger and overwriting input merger. Let's see what it does. Okay? Here I write as like a sample, okay, of what it's going to be done by the framework, but I didn't want to do it in a demo because it's not going to work for sure. So imagine that you have two workers, and the first one, it's going to send as a data, name, key, Jose Luis, age, 28, city, Seville. And the next one, the other one, sorry, it's going to send as a key, name, Marc, age 30. The overwriting input merged, the result of this, it's going to be that. Name, Marc, age 30, city, Seville. Why? Because it's going to take the latest one. So at this point, it was Marc. And the one that it didn't exist in the Marc, it's going to be added. That's all. Simple. Next one. Ay, al revés, aquí. A write creating input merger, the same example. And the result, it's different. It's going to wrap it inside of a write. And the order is not a guarantee. Okay? So here we can find as a name, we have an array of Jose Luis and Marc, age 28 and 30, and city, Seville. That's something that you need to take care of this, okay? Or use different keys, and that's all. Up to you. Okay. And we are starting to finish. When we can or should use it? For me, and this is a personal thing, okay? This is not write it down in the documentation. The task or the execution, the business logic that I want to execute need to be required to be guaranteed and constraint aware. If not, I will use a thread, normal thread. I'm not going to use this because this is heavy. It has a state machine. It's going to be persisted, and even when I know what they are going to do, I cannot be sure, okay, in which state everything is going to be. So if it's something that I need to be guaranteed and constraint aware, I will use it. For example, daily task or routine task. updating the caches, indexing the data. Imagine that you have a big SQL and you need to index more information to do quick search. Okay, so you can do it. Or for example, upload photos. Why I say that? Because most of the applications in the world, every time that you want to upload the photo, you need to be stuck in the application until the photo is successfully uploaded to the server. Why? Because with this, we can say, okay, let's create a work request. We send the URI of the photo, and we say to them, need to be with internet, and we enqueue in the WorkManager, and that's all. And we don't need to block to the user. We just define in the UI a state that say it's uploading, and that's all. Okay, and this is a heavy task, and we can delegate it to them because, for example, if the application, the user closes it, you don't care because the next time it's going to be uploaded or the operation system kill the process. For me, this is the conclusions of everything. Guarantee constraint-aware execution, I already say, respectful of the system background restrictions. Why I say that? Because it's an abstract API. You don't know what the library is going to use, so I can be sure that they know more than me. So they are going to know when an alarm manager needs to be sent, or a job scheduler, or a thread, etc. Backwards compatible. You can use it right now. Because if you don't have API 21, it's not going to use the jobs. It's going to use the alarm manager. So we can use it. Queryable, we can fetch information from the workers. Chainable, we can create an atomic operation of request. And opportunistic. Why I say this? Because it's, for example, when I explain the policies in a work request, the keep, replace, append, this is best effort. Okay? And that's what I say and repeat every 5 minutes in the talk. Everything is best effort. If the work is already executed, they cannot guarantee you that they are going to cancel to replace it, for example. So this is the only thing that, but anyway, I think that it's a pretty complex thing to solve. And that's all, okay? So questions, or I spoke too much? Who is using it? Yeah? In which business law?
Sign up for Argentina government. So in order to download the license driver of the citizen, we use it.
The one time or the periodic?
Periodic, once per day.
Okay, and before you were using another thing?
No.
Oh, okay, that's the first. Okay.
Is possible to cancel?
Yeah.
For some cancellation?
Yeah, here you have it. You can cancel by tag, you can cancel by request ID, and you can cancel all if you want. Here, at the bottom. Cancel everything, cancel by tag, cancel by unique, and by request ID.
But the cancellation is not immediate or?
Best effort. Yes. They are going to send the event of please cancel everything, but if something was executed, they cannot guarantee you that it's going to be canceled. So you need to be kind of aware of this behavior. Something more?
If the user kills the app, does it still get executed?
Yeah. They say that it's guaranteed to be executed. And depends, for example, if it's a periodic work request, and you say every 1 day, it's going to be executed. If the application is closed, they will open they will start the process. Because they are going to use, for example, the alarm manager. And the alarm manager has the possibility to do that. Okay? But if, for example, it's a one-time, I don't know, but I don't think so, that the application is going to be launched. But maybe yes, because they don't specify in which condition they are going to use the job scheduler or the job manager. They only say with the APIs. If you have API 21, you are going to use the job, but when they are going to use the thread, because they say that they can only send maybe a thread with an executor, and that's all, and you forget about it. So with the periodic one, for sure, because it makes a lot of sense, and they say, but with the one time, I don't know. I didn't test it yet. Something more?
The unique work is to avoid the concurrency, or you need to do then, like if you would have changed the then, to avoid race conditions and so on.
It's basically, honestly, I think that it's only because as they didn't have the policy, you cannot specify here the policy. So, but you can have multiples, maybe, for the same. So here they give you like a context of, okay, give me a unique ID of this operation or of all of these operations, and that's all.
So there is a way to avoid this rest condition, to that, for instance, 3 works are done in at the same time, or?
You cannot specify that. I mean, it's when you, for example, use the list of work requests, can be executed in parallel, but you don't know. And also depends of you. For example, if you modify the executor in the work manager, as I said, you have a set executor. If you modify that, you kind of know it. Because, for example, if you set that a multi-thread executor, and you say 2, 3 threads, but you know that it's probable that it's going to be in parallel. But you can say, for example, a single thread executor, and that's all. And everything is going to be not concurrent. And if you don't know your code, I mean, I imagine if you enter in a new code that it's quite big, and you are going to use this, I will put it in single thread just in case. Okay, okay. So that's nice that you can configure. I think that it's here. But yes, everything is best effort. Another question?
Can you schedule a periodic work? There is some interval minimum or maximum?
For what? Sorry?
For the periodic work, there is a minimum interval. Can we schedule a periodic work, for example, every minute? Or
Yeah, you can do it because you define you have 2 ways of defining, but I only put one, okay? You can say the time unit, and you can say, for example, time unit second, and the parameter is 1. So every time it's 1 second. And then you can define, for example, when you want to start with an initial delay. That's the only configuration that you can do.
But there is a restriction because
for example,
scheduler,
yeah?
API, there was like, I think the minimum interval was 15 minutes.
Ah, no, they didn't say anything at all. No. And I checked the comments of they didn't put it. It's a good thing to check. But again, it is an abstract API, maybe when you define 1 second, they are not going to use the job manager, the job scheduler. They are going to use alarm manager or another thing, another way to do what you want to do. So that's the beauty of this, okay? Something more? I must say that in 6 years of working on Android, I kind of like, okay? It's the first time that they launched something, a developer library, that I like a lot. Because it's, what I really like is that you are completely like decoupled of the framework itself, okay? You don't have many options, you don't have anything. You have one way of doing it, and behind, they do everything. And you don't need, for example, the typical context in the work request or something like this, okay? So I pretty like, I will start using it. Okay, I think that's all.
Well, thank you everyone for coming another time to another Barcelona Android Developer Group meetup. As you know now, we have some beers and pizza to have a good networking thanks to this idea. So glad to see you and let's eat.